Okay, for lab number 2, we're going to actually do a lab based on a data set that we're going to import, which is for insurance fraud detection. So let's create a new workspace name. Maybe let's name it lab 2. Okay, and make sure that our subscription is Azure for student. Okay, for resource group, same thing. Let's create a resource group called lab 2 so that we can actually delete later at the end of the lab. Okay, click OK. For region, select Southeast Asia, click create. Okay, as mentioned earlier in lab 1, okay, the creation workspace will take about 3 to 5 minutes. So let's wait a while the workspace is being created. Okay, the workspace has been successfully provisioned as can be seen on the screen. Let's go inside the workspace. So for today, before we actually go into Designer to do our pipeline, we will actually need to import our data set. So on the left hand panel, click on data. Okay, and we're going to create a new data set. Click on create. Okay, we're going to name our data set as insurance. Okay, because it will contains all the different features or the columns or the parameters that we're going to use for insurance fraud detection. The type tabular, because we're going to actually import a CSV file. Next. Okay, we're going to select from local files. Next. Okay, we're going to store our database inside the workspace prop store, so leave it as default. Next. Okay, and click on upload button. Okay, and because I've already saved my CSV file on the desktop, so this is the file that I'm going to select. Okay, module 8 insurance CSV, open. Okay, click next. Okay, if it's a valid CSV file, you'll find that you'll be able to see all the columns that is going to be imported. Okay, leave the format as limited, comma, etc., so that you can actually see the properly formatted CSV file. Click next. Next again, and create. Depending on how big your database file is, it will take us time, but our database file is not very big, so we actually import is quite fast. So after importing of the database, we can safely go to designer mode to create our pipeline. Similarly, after clicking on designer, click on create a new pipeline using classic pre-built component. Okay, so click on the double arrow so that you can expand all the components that you're going to drag onto the workspace. Okay, so the first thing, basically we're going to grab our data set, which is on the data tab. Just drag and drop in. So if you actually click on the pin or the box, right click and preview data, you'll be able to see the data that we have imported earlier from the CSV file. You'll find that we have 69 columns. That means that 69 different features, and we got 1000 rows. That means 1000 different entries. If you click on the profile, you will be able to actually see what the different columns, what are the different columns in terms of the type, whether is it an integer or a string, and what is the minimum and maximum value for every individual features, how many counts of entries are there, so is there any missing value, empty count, error count, what are the mean value, etc. So from here you can actually even see what are rows that contains missing count that you're going to clean up the data later if you think there is a need to. So once you have actually visualize what your data is containing, you can actually close the tab. And basically the next step is to start to form our pipeline. So the next component that we're going to drag and drop is basically the edit metadata. So just type edit then meta. You will find the edit metadata component is out. Drag and drop under the dataset insurance, and link it up. So basically, okay, for edit metadata, okay, because we're going to actually edit one of the features, okay, in the data set, which is the column fraud reported, because currently you can see that it's basically integer, is an integer value, but it makes more sense to actually change it to a form of yes or no. Okay, so basically double click on it, okay, edit column, okay, and we're going to select our fraud reported column, which is here. Okay, save. Okay, then for data type, okay, as mentioned, we're going to change from integer to string, and category, okay, we're going to categorize it, okay, as yes or no. Okay, and for field, basically I'm going to put it as label. Okay, so that will be the three selection that we need, okay, for this component. Okay, so next we're going to actually choose another component, which is your filter. Okay, filter based feature selection. Okay, because for our data set, you can see that there are so many different features, and at the start it's very hard to actually determine what are the features that we want to use, okay, for our our analysis or prediction. So we're going to make use of filter based features selection to let it try to select a desired features based on certain statistical logic. Okay, so link up between edit metadata and filter based feature selection. Okay, double click on it. Okay, so edit column, same thing. Okay, we're going to need to actually key in fraud reported, FRAUD, okay, REPORTED. Okay, make sure that you type in correctly. If not, okay, you won't be able to select the appropriate features that is in the earlier data set. FRAUD. Okay, if you've forgotten the name, okay, you can actually just go to the previous, okay, and make sure that you can basically just copy and paste, okay, in order to get the actual correct name. Okay, so for reported, for the filter based feature selection, after selecting the columns, okay, in order for it to select desired features. So currently you can see the number of desired features is 1. Okay, definitely we cannot depend on one features in order to analyze our data. So I'm going to change it to 35. Okay, going to change it to the 5. Okay, so that will be all the information that we're going to key in for filter based feature selection. Okay, for the scoring method, basically is going to make use of person correction, okay, which is a statistical model. Okay, you can actually close the properties now. Okay, so you can see that on filter based feature selection, okay, on the left hand side basically is the filtered database, okay, which is going to contain only 35 feature sets, whereas on the right hand side will be the full data set with all the features. Okay, so the next components that we're going to drag out is the smoothie component. Okay, so what does the smoothie component do? Okay, basically it will actually helps to increase the number of rows for the underrepresented data. That means it create actually more rows, okay, for the underrepresented data. Okay, so that means that, for example, for fault reported, okay, the the fault reported, okay, may be no fault reported may be in terms of 700, but the no fault reported may be in terms of 200. So we may want to create more detection of fault reported in terms of instead of 200 to 400 to 600, so that it will actually and maybe enhance the learning of our data to better able to predict fault detection. Okay, so we're going to link up the filter database from here into the sample. Okay, and for the smoothie, okay, as mentioned, doubling on it. So the percentage by default is 100. So we're going to change it to 200. So that means we're going to increase the underrepresented data by a percentage of 200. Okay, close it. Okay, so the next that we need to actually drag out will be the split data, to split between the training data and the testing data. Okay, so out the splitting of data. Okay, and we're going to drag the smoothie, connect the smoothie component to the split data component. Okay, and double click on it. So change the percentage to 0.8. Okay, for today we're going to use a ratio of 80% and 20%. That means that 80% of data will be used for training, whereas 20% of the data will be used for testing. Okay, so for today, because this is a categorized training model, okay, so instead of using linear regression, okay, we're going to make use of a model which is basically a two class, because we're only going to actually predict whether is there a fault or there is not a fault. So two class, boosted, decision tree. Okay, so from the two class boosted decision tree, let's drag out the component onto the workspace, and after that we're going to actually drag out our training model component. Okay, so after dragging out the training model component, link up the two class boosted decision tree to train model and the split data into our data set, and double click on the train model, and click on edit column. So basically the column that we're going to actually train it to actually predict basically will be for the fault reported. Save. Okay, so as mentioned, make sure that you key in a correct feature name. Okay, in this case will be fault reported. Okay, so the next component that we're going to drag out will be the score model. Okay, so basically for the score model, drag connect up the train model to the training model. Okay, so for this lab itself, we also trying to compare between different types of training model. Okay, that's the reason why on top of just connecting the training model of using two class boosted decision tree, you will find that later on we are going to make use of another training model, two class regression training model. Okay, we can actually see it in our lab diagram. Okay, let me just scroll all the way there. Okay, so basically currently we have our two class boosted decision model, training model, and the score model split data. I need to actually connect to the score model. Okay, so this will be the connection that we have currently. Okay, training using the two class boosted decision tree. Okay, and you can actually also drag out the evaluate model. Okay, so that we can actually compare between the two different train model that we're going to use later to do the comparison. Okay, so basically we're going to actually connect to another set of training model, which we're going to see later. Okay, so you can see that there's another set of training model, so that later we can evaluate between whether a two class boosted decision tree is better or a two class logistic regression model is better. So similarly, basically, we're going to drag our train model out. Okay, just place it here. Okay, and we're going to drag as mentioned in the lab two class logistic regression. Two class logistic regression. Okay, just drag it out. Similarly, put it here. Okay, and we're going to drag another score model out. Okay, which is this here. Okay, let's place it just below so that easier for us to see. Okay, so similarly, okay, so this will be for the untrimmed model. We're going to connect this here. So should be wrong. Okay, let's delete first. Okay, let's drag our trim model again. Okay, so for trim model, untrim model will be connecting to here. Okay, and the resultant data set from the split model will be to the data set. Okay, and this will be connected here, and the resultant data set from the split data will be connected to the data set. Okay, so that will be what you are looking at now. Okay, just make sure. Okay, so basically the split data, okay, the resultant data set will be going into the two training model of data set. Okay, and the untrained model will be using two-class post-division, two-class logistic regression. Okay, and the output from the trained model will be going to the trained model pin of the score model. Similarly, the other side, trained model, and the result data set of the split data, the 20% will be going into the score model. Okay, which you can compare here. Okay, split data. Okay, and then we're going to actually evaluate the two score model by actually piping the output to the evaluate model, which will be the end pipeline that we have. Okay, so for the evaluate model, after you click on it, that basically there's no parameter. Okay, this is score model, model for reported. Okay, make sure that you key in for both. For reported, save. Okay, FRAUD underscore reported. FRAUD reported. So once you have completed your pipeline, it will basically looks like this. Whereby your data set will go through the edit metadata to change the fault reported column to a string or category feature set. And you will basically only select 35 features to be used in the detection of fraud. For Smoothie, you will actually increase the percentage of the underrepresented data. From there, you will split your data set into 80%, 20%. 80% will be used for training using two-class boosted decision and two-class logistic regression. Then you will actually score the two model based on the 20% testing data, and you will use the evaluate model to actually evaluate which of the training model is better. Click on submit. So you can see that when click on submit, there's an error because we haven't created our compute resource. So click on setting, select compute instances. Create Azure ML compute instances. You can leave everything as default. Create. Let's wait a while for it to be created. Has been successfully created or provisioned. You can actually slide it now. Minimize. The reason why there's error for Smoothie because the data set hasn't been created yet. So you can actually just submit anyway. So there's no existing experiment, so we can create a new one. Let's name it as Lab2. Then submit. So while it is in the midst, okay, so just now actually I said actually forgotten to actually edit the column to include the fault reported. That's the reason why it actually give me an error. Okay, give me an error. So we have add in the column name fault reported, in order to actually increase the percentage of the unrepresented data. Okay, so you can see that the pipeline has successfully been created. Okay, you can click on the job detail, whereby actually brings you to the jobs to look at the job that is being running. As per the running of as per the running of the pipeline, you can see that basically similarly we normally need to wait about 20 to 30 minutes in order for the pipeline to actually successfully go through the different stages of the component before we can actually evaluate the data. Once the pipeline has successfully run and completed, that means the job has been completed, you will see that all the different components is been executed properly. Is highlighted in green, means that it's been executed correctly. If you encounter any error in case of any components that is indicating red, it means that there's some parameters or options that you have never select properly, which you may actually go back to the designer mode to actually reconfigure it before you actually run the job again. But since we have actually successfully run the job, let's look at the output of all the different components that we've actually uh, uh, actually created, as well as process it. So you can see that after the edit of metadata, basically if you right click preview of data, you'll be looking at this. So the basically for the result data set for the edit metadata is basically to change the column for reported to be in the form instead of represented by a value of 0 and 1, we actually change it to categorical label. That means that I only have two unique value, yes or no, which have successfully completed it. For the filter feature set, which basically we're only selecting 35 features out of the 60 over features. So if you right click on it and preview data, you'll find that there's only 36 column that is inclusive of the fault reported features. Close this. So the Smoothie basically is to increase the unrepresented data in terms of fault reported. You can see that previously, the fault reported, the underrepresented data is the fault that is being reported. So you can see that the two bar chart is actually in different proportion. So at the output of the Smoothie, basically if you right click and preview data, you will find that the fault reported, whether it's yes or no, is now of equal representation, and the number of rows has actually increased to 1,494 compared to earlier. The number of rows is basically only 1,000. So the splitting of data basically 80%, 20%. For training using 2-class posted decision tree and 2-class logistic regression. If you look at the score model for the 2-class posted decision tree preview data, this is fault reported, and you scroll all the way to the end, this will be the score label on how accurately the training model is able to predict the score, whether the different features that relate to each other, does it really indicating a clear-cut reporting of fraud or not. So similar, if you look at the score model for using the 2-class logistic regression under preview data, scroll all the way to the end, you also be able to see the score model. But by just looking by it using naked eye, it's very hard to actually compare whether which of the model is better. That's the reason why we make use of the evaluate model to actually compare between the two training model. So right click on it, preview data, and basically you will be able to see the evaluate result in terms of the ROC curve. So the best curve is basically the curve that is most nearest to the upper top left hand corner. But you can see that both green and blue, which is basically representing the training model using two class poster division tree, and the two class logistic regression tree are quite similar. So there is no clear cut winner here, whereby which training model will actually predict each row for better. Okay, if you scroll down all the way, you will be able to see the accuracy of the model in terms of 0.8886, basically is 88%. Chances of it being predicting correctly. So basically these are all the different parameters that you can actually look at in order to determine how accurate your pipeline is in the predicting of the data set using the different features. So as mentioned, there's no right or wrong. You instead of using that 35 feature set, you may actually change it to more feature or even less feature for all these readings or the prediction to be much more accurate. Okay, so after analyzing all your data and capturing of your data, the last part of the lab basically before you actually end the lab, basically always remember to delete all resources and don't let it consume the charges while your resources are still being provisioned. So basically right click on the upper right hand corner and click on the resource group to bring you to the Azure portal. So from Azure portal, click on delete resource group and basically key in Lab2 because that is the resource group name that I've actually given to this resource group that contains all the resources that are used for the analysis. And click delete. So you can click on home to go out to the main workspace home portal before click on Lab2 again to make sure that you can see the deleting before you actually close your browser to end the lab.